Welcome to the part 3 of the Blender 4.5 course. In this part we're going to work on the rendering section. You can access to all chapters and the other parts from the playlist here, and also the link is in the description. Rendering in Blender has two main sections. One is the material view that we assign a material or coloring property and textures to each 3D model, and we can see the preview of the color and textures, and finally the material of the 3D model. And the next section is the final render that we can see the lighting, the shadows, the materials, and post-processing in the viewport, and also can render a final image or animation. If we want to explain about other phases, we can say we have the solid view. This is a solid view. We can see all the 3D models in a white color or kind of white color, and we can't see any shadow or lighting effect. Also, we have another view which we can select it from here. Here, this is the wireframe view. I will upload every chapter of the course every week, so make sure to subscribe to the channel and turn on the notification to know about the new chapters and new tutorials. We can see the edges and vertices and points of every object. Here you can see the complexity of the UV sphere, and also this and this. And as I said in the previous part, the plane object is the lightest 3D model in the Blender, and actually all 3D software. This is the material view that I explained, and as you can see, all the 3D objects are white because we didn't actually assign material and texture and no color to the 3D objects. Also, we can see a default shadow. This slide, as you can see, we move it and we can't see its effect on this shadow. We can see the effect of this light and other lights only in the final render. And here, if I move the light, this is a point light and represent a light just like a bulb, and you can see the light position and the shadows are changing. And this is the final render. Also, we can press the Z key on the keyboard and switch between all these status. We have in the rendered view, we can go to the solid, we can go to the material preview, and we can go to the wireframe. Now let's talk about the render engine. Many 3D software offers just one render engine. For example, Maya offers Arnold 3D engine. Cinema 4D offers Octane render engine. But in Blender we have two 3D engines. Here in this menu we can access to the render engines and switch between them. The default one is the Eevee render engine, which we have access to the improved version of Eevee engine after Blender 4.2. Actually, this is the Eevee Next, and removed the vanilla and the traditional Eevee engine in the Blender 4.2 and renamed the Eevee Next to Eevee. And now this is the upgraded and improved version of the Eevee, and this is the real-time render engine. And in the other hand, we have Cycles. Cycles is the offline 3D engine, which means for rendering a single frame, we need to wait, and it takes a while to render based on the render quality and the 3D objects in the scene and the complexity of the scene and lights and shadows. But in the real-time 3D engine, we can see everything instantly, just like game engines, for instance Unity, Unreal Engine, and so on. We can see everything in real time, but the quality is not same as the Cycles. Cycles is useful for cinematic projects, for movies, for top quality animations, but Eevee is sufficient for a quality near to the video games. Now let's switch to the Cycles, but let me give you this advice. First go to the solid mode and quit from rendered view and then switch. This is better because sometimes switching to the Cycles in render view results crashing the Blender, and sometimes you can't open the Blender again. You need to restart your PC because the background process of the Blender is still active, and you need to find it in Task Manager and end it, and finding it is hard and takes a while, so restarting your PC is better choice. Here, let's go to the rendered view using the Z key. Here, as you can see, rendering a single frame takes a while. You can see a sample count here. Sample count means the quality of the render, and as you can see we have some noise here and here, and higher number of samples destroys these noise. But we can make it faster, make the cycles faster if we change the device to the GPU, not CPU, because GPU has many threads and cores, and it is very useful for image processing. The rendering process is a kind of image processing, and GPU is very fast for this job. But I need to say that NVIDIA GPUs are better and give you a better performance for GPU rendering. You can use AMD or Intel GPUs to render the scene, but NVIDIA is faster because of CUDA cores. You need to go to the edit menu and go to the preferences. Here, if you have NVIDIA GPU, you can select the CUDA, and if you have an AMD GPU, you need to select the HIP or HIP. Right, I selected CUDA, but I need to switch to the GPU compute. Here, as you can see, the samples much faster. Let's compare the cycles with Eevee. I switched to Eevee, but I don't quit from render view. And as you can see, we have big differences, but we can improve the Eevee. I'll explain it later, but for now let's focus on the Cycles. Cycles has two sections: viewport and render. We can specify the attributes for the final render, and we see those attributes only in the viewport mode, but in the render we can see these attributes on the final render, which we can select this menu and press the render image or press the render animation and go to the rendering section, and we can see the final render here. This section is related to this view. Here in the viewport, the default value for the max samples set to 1024. It means the samples need to be reached the max sample, but as you can see in the 50 it stops and says rendering done. So why? Because an option called noise threshold is activated. Noise threshold means we have rational count of noise, and if we reach a rational count, we don't continue the rendering process. If we disable this option, as you can see, it will grow up to 1024, and as you can see, we have a softer result and noise is disappearing. Also, we can activate an option called denoiser, and as you can see, the rendering process is so slower now, but we have a stable and good result at 20 or 30 samples, and we don't have any noise here. Let's see. As you can see, we have 5 samples and we don't have any noise here. Denoiser should be activated in the final render, it is better, but here we need to deactivate it because it will make the process very slower, and we don't want it for the viewport, because actually a preview final render is sufficient for the viewport rendering. For the final render, the max sample is very larger than this value. We can specify a value based on our needs. Mostly I use 500 or 600 for my personal renders and use denoiser for the final render. Also in denoiser, these two denoiser are similar. We have two options, optics and open image denoise. This option is better. We can also balance the other attributes, for example, to final quality of the denoiser. Let's check here and change the quality, for example, to fast. And here, as you can see, the render process is much faster. Let's switch to high, and as you can see, this is very slow. Now, as you can see, the differences between cycles and Eevee, especially in the shadowed areas. Can we make the Eevee better and near to the cycles? Yes, we can. In the new generation of Eevee engine, we have a capability called ray tracing. This is a software ray tracing, not like hardware ray tracing provides in most video games. This is software ray tracing. It means if you don't have GPU on your PC, it works. If you have a cheap GPU on your PC which doesn't have a ray tracing system, doesn't matter, it works. Just turn on the ray tracing, and as you can see, the result is very better in the shadowed areas. Let's see, and this is the final result. And let's switch to cycles and see the result. It's near to the cycles, but the quality is still lower, but it's worth it because we can see the result in real time and we have a almost good result. We can modify the attributes and properties and balance them. In the resolution, 1 is the best resolution and this 16 is the lowest resolution. In the screen tracing, can change the properties, for example precision, and increase the precision of the ray tracing process, also the thickness of it. And here we have a description, and it says surface thickness used to detect intersection when using screen tracing. In many cases I use a high value, something like 1 or 2. Let's change it to 2, but changing it is not very useful here because our scene is not too complicated, but let's change it to 4. And here, as you can see, let's switch back to the 0.2, and here we have darker areas, and in the 4 value we don't have darker area. Here we have the same process here, and actually with the high values we have more indirect lighting in the scene. I will talk about the indirect lighting and the techniques of it in the future videos. The denoising section is not similar to the cycles. If we disable it, as you can see, we don't have a very big difference. It's not too obvious. And also in the fast GI or global illumination or indirect lighting, we have several options related to the indirect lighting that, as I said, I will talk about it later. It's complicated to talk about in one video. We need to work on it in the future video. Alright, in the next chapter I will focus on the lights and cameras because you are familiar with the rendering now and we're ready to work with lights and some advanced stuffs.